This is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In this session, we are going to see about knocking and also about the octane number. So, we are going to see about knocking, chemical structure, and knocking, anti-knocking characteristics, octane number or octane rating, leaded petrol, and mechanism of knocking. So, what is knocking? So, you would have come across this term. It will be a familiar one, those who are using vehicles. Knocking is a kind of explosion due to rapid pressure rise occurring in an IC engine. So for example, the damaged piston of heavy engine knock. Causes of knocking. In petrol engine, a mixture of gasoline vapor and air at the ratio of 1:17 ratio is used as fuel. This mixture is compressed and ignited by an electric spark. The products of oxidation reaction, combustion, increases the pressure and pushes the piston down the cylinder. If the combustion proceeds in a regular way, there is no problem in knocking, but in some cases, the rate of combustion, oxidation will not be uniform due to unwanted chemical constituents of gasoline. The rate of combustion will not be uniform due to unwanted chemical constituent of gasoline, so the rate of ignition of the fuel gradually increases and the final portion of the fuel-air mixture gets ignited instantaneously. Producing an explosive sound is known as knocking, and the knocking property of fuel reduces the efficiency of engine. So a good gasoline should resist knocking. Chemical structure. The knocking tendency of fuel hydrocarbons mainly depends on the chemical structure. The knocking tendency decreases in the following order. First comes the straight chain paraffin, which has a greater knocking tendency than the branch chain paraffins, which is greater than that of cycloparaffins, which is greater than that of olefins, and that is greater than that of aromatics. Thus, olefins of the same carbon chain length possess better anti-knock properties than the corresponding paraffins. Improvement of anti-knock characteristics. The octane number of fuel can be improved by blending petrol of high octane number with the petrol of low octane number, so that the octane number of the latter can be improved. The addition of anti-knock agents like TEL, that is tetraethyl lead. Nowadays, aromatic phosphates are used as the anti-knock agent because it avoids lead pollution. Now we can see about what is octane number and octane rating. So octane number is introduced to express the knocking characteristics of petrol. It has been found that N-heptane knocks very badly and hence its anti-knock value has been given 0. On the other hand, iso-octane gives very little knocking and so its anti-knock value has been given 100. Thus, octane is defined as the percentage of iso-octane present in a mixture of iso-octane and N-heptane. So we can see the structure. Iso-octane, or it's called as 2,2,4-trimethylpentane, which has the octane number of 100. Heptane, which has the octane number equal to 0. Leaded petrol. Leaded petrol, it is an anti-knock agent. The anti-knock properties of gasoline can be improved by addition of suitable additives. That is, the tetraethyl lead, as we already discussed, is an important additive added to petrol. Thus, the petrol containing tetraethyl lead is called the leaded petrol. Mechanism of knocking. This tetraethyl lead reduces the knocking tendency of the hydrocarbon. Knocking follows a free radical mechanism. It leads to a chain growth which results in an explosion. If the chain are terminated before their growth, the knocking will cease. So tetraethyl lead, it acts as an anti-knock agent. It decomposes thermally to form ethyl-free radicals which can combine with the growing free radicals of knocking process, and thus the chain growth is stopped. So there are certain disadvantages of using the tetraethyl lead. The leaded petrol. which uses it is converted into lead oxide and metallic lead. This lead deposits on the spark plug and on cylinder walls, which is harmful to engine life. To avoid this, small amount of ethylene dibromide reacts with the lead and lead oxide to give volatile lead bromide, which is exhausted. So we are adding to remove the excess of TEL by ethylene dibromide. So we can see the structure in which lead bromide is escaped as a gas. It's volatile compound. Then aromatic phosphors are used instead of TEL to reduce pollution. Thank you.